So in this last video, I wanted to make sure that you're familiar with the terminology of the test equipment that's used to measure all of those fundamental electrical quantities that we've talked about up until now. A multimeter is really the most fundamental piece of electrical instrumentation that exists in the marketplace. And as the name implies, the multi-part, it's used to measure the meter part, a variety of electrical phenomena. At minimum, any multimeter that you have will be capable of measuring voltage and current. Routinely, it's capable of measuring additional quantities beyond that, things like resistance, capacitance, and so on. Now, when you think about a multimeter, it's obviously measuring different types of quantities, and when it's used to measure voltage, it's actually referred to as a voltmeter. So it's a little bit confusing in that even though the instrument itself is called a multimeter, when it's measuring voltage, it's being used as a voltmeter. In a similar fashion, when a multimeter is being used to measure current, it's referred to as an ammeter. One thing that you should know, an acronym that you want to be familiar with, is DMM. Oftentimes, if you work with older engineers, they may be familiar with working with analog multimeters. When the digital variety came out, it was an incredible breakthrough because there was no longer the need to read the actual value from kind of a continuous dial. It really automated the workflow quite a bit. So because of that, the actual digital multimeter is often referred to as a DMM. One thing you should know about multimeters is they vary dramatically in how they look. That's the form factor and how much you can pay. So as an example of that, on the upper right, I've showed you an example of a handheld multimeter. This might be something that an electrician would use or someone that's just doing quick troubleshooting out in the field and really doesn't care about the precision or quality of their measurements versus if you're actually in a laboratory type environment and you need to take very accurate and precise measurements, particularly of voltages and currents that you would encounter in more of an electronic environment, you would use a benchtop multimeter as is shown below. And note the price discrepancy between these two things in addition to the actual physical size discrepancies. Another thing you should know about a multimeter is whether you're actually looking at the test leads, these are the probes that I'm moving my mouth over here, or the ports to which you connect the probes, they're color-coded. And that implies that these measurements are actually polarized, meaning that if you were to swap the leads for a given measurement, you would expect that the value would differ. And particularly, the value would generally differ by plus or minus difference. And when you have a multimeter configured in voltage mode, so it's operating as a voltmeter, the voltage that is measured by convention is from the red test lead to the black test lead. So if you were to measure a voltage red to black, and the quantity were to read out negative, that just means that the potential at the black node is higher than the red node. If the quantity reads out positive, that means that the potential at the red node is higher than the black node. So one thing that you want to know about taking measurements with a multimeter is if you're measuring voltage, that measurement is actually made in parallel. You connect the instrument in parallel across the component that you're trying to measure the voltage. And because of that, if you think about it like connecting in parallel across a resistor, if you don't want to modify the voltage that you're measuring, then you don't want any current to actually pass through your multimeter. And in order to achieve that, the internal resistance of a voltmeter has to be infinite. So oftentimes we'll say that the internal resistance of a voltmeter acts like an open circuit. And that just ensures that no current goes into the voltmeter, thereby modifying the voltage measurement that you're trying to make. In a similar ideal, when you actually measure current, or when a multimeter is operated in ammeter mode, that should say, before I forget, I will swap that out. You're going to connect the meter in series, and the current that you're measuring will actually pass through the meter. So again, if you don't want to modify the current that you're measuring, in that case, the ammeter rather, will have to have zero internal resistance. If it had any resistance, it would reduce the current. So we say that the internal resistance of an ammeter is zero. Another way to say that is that it acts as a short circuit. So just a little bit of terminology there to make sure you're familiar with the basic idea of electrical instrumentation, particularly multimeters.